Hello, welcome to this Google Hangout. Good evening, good afternoon, and good morning to all our viewers all over the world. This is in the series of Hangouts that we have been doing, and I hope you enjoy those Google Hangouts. And we have been getting requests for many more topics. Based on those requests and based on some interesting scenarios that we see happening in the customer place, we are bringing you this interesting series, this interesting topic today about how do you build hybrid data cluster using MongoDB and PostgreSQL as a database. The world is all about coexistence of multiple technologies. And what Samir today is going to present is how do you bring new technologies and existing technologies together for business benefits. So enjoy, and you can ask the question, or if we are short of time, we will come back to you with the answers after the hangout. So relax and enjoy. Samir, over to you.
Thank you, Sachin. Thanks a lot. Hi, everyone. I hope you would have enjoyed our past hangouts, which had been based on streaming replication, performance tuning, and JSON data types in Postgres 9.4. If you have not already done that, please go out and check them out. You will find them interesting as well as helpful. So to go ahead with the hangout that we have to do today, let us look at that. This will be about building a hybrid data cluster. Why hybrid? Because we are talking about having our coexisting databases, MongoDB and Postgres. One of them is ACID compliant relational database and having some NoSQL features, whereas the other one is a full NoSQL database which has sharding capabilities and has quite less ACID compliance compared to Postgres or compared to any other relational database. And we will see how both of them can leverage and take advantage of the features of each other. Let me put a context and an actual real life scenario in front of you guys so that you can relate to that, and then maybe you can think that this is something that you also would be interested in. Today, we see that more and more data which is getting generated is actually unstructured. A lot of data that has been generated in the past couple of years has been unstructured. And there are a lot of use cases, user scenarios where NoSQL databases make a good fit. In addition to that, there is a continuous requirement to have horizontal scalability in your environment nowadays. But at the same time, you have these challenges while dealing with NoSQL databases that a lot of administrators and developers would still prefer SQL as a more intuitive language to query the data that you have, because they have been using this for a long time and they understand that language in much better way. Plus, SQL queries can be much more complicated, can be complex. You can have joins, you can combine multiple entities. I'll be using the word or the term entities more often because that is a more real life or a more real time word, whereas when we talk about relational databases, entities translate into tables, which could be one table or multiple tables corresponding to the same entity. Similarly, when we talk about MongoDB, entities translate into collections. So in this hangout, I might be using entities word more often than tables or collections. So that's why I thought I would give you a context about that. Now, not many NoSQL databases would allow you to combine these entities together by using joins as efficiently done by SQL language. So these are some challenges, and there is a real need for NoSQL databases in a lot of places today. Now, some real life cases are, which we have dealt with in recent past, is we worked with a customer who wanted to have a sharded or rather a distributed data store for which would work as an archive for their actual operational RDBMS or the actual transactional RDBMS database. Their requirement was very clear that we want to put or we want to archive our data to a distributed data store, but at the same time, we should be able to access that data via SQLs. Another customer that we have come across like 3 months ago, they were using a very popular NoSQL database to act as a receiver from multiple write streams. Their idea was this is flexible. I don't have to do any application coding changes. I don't have to expose any kind of APIs. All my customers, or rather all my users, could be sending their write streams into this NoSQL database, and I can shard it. I can receive huge amount of data, which is varied in its structure, and then I have my algorithms. I have my people who will filter it out, structure it, form tables out of that, and then we would use them in a relational store like PostgreSQL, where I can write all the complex queries, all the inner queries, or all the sub queries, and get result or reports out of that data. So these are two very practical scenarios which we have come across quite often. I would say both of them we have come across more than once. And that is why we thought that let's see how to deal with these scenarios in a more efficient way. So what we came up with, a hybrid data cluster, which is what all of us need today. And we are going to show you a small demo of how we have proposed to all these customers to build a hybrid data cluster using technologies PostgreSQL, MongoDB, and foreign data wrappers. PostgreSQL, as all of you know, is the most advanced open source database. It is based on the relational model, and it supports ACID features for the transactions. It has multi-version concurrency controls for providing consistency, and has write-ahead log files for providing durabilities for your transactions. It also has a concept of table spaces and partitioning, which allows you to scale vertically to a certain extent within the same server. It also supports a lot of modern day data types like HStore, where you can store data in key value pair, or JSON, or the newly introduced JSON-B data type, which allows you to store data in JSON format. It also supports full text search. So PostgreSQL in itself is quite feature rich. And then we used MongoDB. We would be using MongoDB in this demo as a sharded data store, which is quite fitting for storing unstructured data, which has got horizontal scalability. And the best thing which I like about MongoDB over a lot of other NoSQL databases is that it allows you to create secondary indexes. And because the way you store data in MongoDB in JSON formats, and you can oversimplify that, and you can just store data as key value pairs as well. You can just have one key in that document, which allows you to cover a lot of workloads using MongoDB. It has some basic aggregation and MapReduce framework as well, which allows you to write some kind of MapReduce jobs or fire aggregation queries on top of MongoDB. But today we are not getting into those things. Today we'll just see how to use MongoDB as a backend database where PostgreSQL is working in front of it. And how is that connection maintained, or how PostgreSQL talks to MongoDB is via foreign data wrappers. I find foreign data wrappers in PostgreSQL as a fantastic feature, as a great feature. It allows you to create foreign tables or create a mapping to external entities. These foreign tables are actually external entities. It is based upon the SQL Med specifications, which are quite standard, which is the standard specification published for management of external data by RDBMSs. Now, when I talk about these foreign tables, like I had said, I would be calling them entities more often. These are actually entities, and these could be a table in another RDBMS like MySQL, Oracle, or it could be an an entity in HDFS, or it could be a collection in MongoDB, or it could be a table in another Postgres database. Now, if you would like to read more about foreign data wrappers in Postgres, you should visit this website that is given on your screens. You will be provided with a copy of this presentation via our SlideShare channel. So don't worry about copying it or writing it down. Now, let's take a brief look at foreign data wrappers for MongoDB and how you would use them. There are quite a few code bases there for foreign data wrappers. One of them is by CitusDB, which was forked by EnterpriseDB later on. And if you would like to get more details about this extension, you should go to the GitHub page of EnterpriseDB and explore more. I encourage you that you go ahead and check that out. A lot of examples that we have shared here, the tables that we have mentioned in this demo, are actually based upon a popular blog from EnterpriseDB that you see on the screen. But you feel free to use your own tables or use your own sharded collections. Go ahead and try this demo on them as well. Now let's continue. The first thing that I did was I prepared a MongoDB cluster. So that is the first part. I prepared a MongoDB cluster. I chose my Windows machine to do that just for the sake of demo. So on my Windows machine, I created few directories which are required. Now I created some so I created few directories which are required for setting up the sharded cluster, for setting up the replica set, and for setting up the config servers. And here are they. The second thing that I did was I created the config servers. Now in Windows, I created them as a service, and then I started that service. As you see, my config server is running on 26050 and 26051 and 26052 ports. This is the standard way how you create config servers in MongoDB. These config servers are important for storing sharding related information. Now we created shards. Shards are basically distributed nodes or data nodes which are going to hold data in MongoDB, and each shard can be a replica set, which means you can have high availability for each of your distributed data node. Now I have created 3 different shards here, and I have created a replica set as well for each of them with just one member. The idea is when I want to take this to production, I can add more members to this whole replica set. So I can add 2 members to each of them and make it a 3-member replica set for each of my shards, so it provides me scalability by having distributed data nodes, and at the same time I can have replica sets which will provide me high availability. So you see I have got 3 of them right now, 3 shards on 27,000, 27,100 and 27,200. These are the ports where I have got them running. Now after creating each of these services, I started them. Like I mentioned, since I'm using Windows, I installed them as a service, and then I went ahead and started each of those services. Now, like I mentioned, just for the sake of demo, I have skipped the creation of other members in this replica set. But if you would like, you can create additional directories, and then for each of these directories, you can start a new node. and you will have to relate them with the primary member by specifying the Resultset config, the Resultset option here that you see, Resultset A in this case, which gets related to the first shard. The next step was to create a Mongo S service. This Mongo S service would contain information about all my config servers. So if you notice, I had created config servers with 26,050, 26,051, 26,052. So as you see on this slide, I'm providing information about each of those config servers, and then I'm starting this Mongo S service. Now, once the Mongo S service has started up, I have to initialize the replica set. Even though there is just one member, since I have defined this as a replica set, I have to initialize the replica set. So for that, you connect to individual shards, and then you have to fire rs initiate command. So when you fire rs initiate, it initiates the replica set, and that very moment you will see that the prompt would change to other, because it is the MongoDB is in process of identifying itself. And then when you say rs.conf, it would identify itself as primary, and the prompt would change to primary. Like you see on the screen, how I have done it for each of the shards. So I had started this cluster with 3 different shards. And then what I need to do is I need to set up sharding. So far what I did was I have started individual nodes. Now I have to tell my MongoDB that, or rather my config servers, that these are 3 different shards that you have to work with. So I'm adding 3 different nodes with command add shard. So all those 3 are added into the in the whole cluster as different shards. And then I have to enable sharding on a particular database. So before I can shard a particular collection, I have to enable sharding on that database. In MongoDB, under one cluster, you can have multiple databases, and you will have to enable sharding for each database individually. Now, once I have enabled sharding for my database DB, like you see here, DB, D for Delta, B for Beta, then I'm going to enable sharding on a particular collection. And while sharding a collection, I have to specify a shard key. This is more or less like partition key when you talk about relational databases, but you have to be very careful while choosing this shard key, because once you have chosen this, it is not that very easy to change the shard key. So you have to be very careful about choosing your shard key. I'm not going to go in more details on what things you should consider while choosing a shard key, but generally you can choose your common query criteria. Now here I have chosen date to be the shard key, and the last argument, which you see as true, signifies that this shard key is going to be unique. So I have kept it as true, but you can also choose a shard key which would not be unique, and its values can repeat, which is just fine. So you can also have a shard key which is false for its unique attribute. Once I have set up my MongoDB cluster, I need to set up the users and security. That is how my Postgres database can talk to MongoDB, by authenticating itself. So for that purpose, I need to create a user in MongoDB. So I'm creating a user, super user here, with a role root. So I'm just creating a super user basically in my MongoDB database. Now once I have set up my MongoDB database, now I need to move to Postgres, where I need to enable foreign data wrappers. and I need to install foreign data wrapper extension. So for that, you can download foreign data wrappers from the GitHub page of Enterprise DB, and then go to the path where you have extracted it and run autogen.sh. This utility will use GitHub and will connect to internet and will download all the necessary components. You can also choose to do this installation manually, and for that, whatever steps you need to follow are also given on the GitHub page. The necessary components which will be installed during this process are libbson and libmongc. Once autogen.sh has completed without any errors or warnings, you can go ahead and do a make install. And once you have done that, the MongoDB foreign data wrapper will be installed on that particular system and configured. Now, Mongo foreign data wrapper that I have referred as Mongo _ FTW in my presentation. It has got few features like it does connection pooling. So if within the same Postgres session you are firing queries on a particular object or a particular entity or a foreign table, it would go and use the same MongoDB connection. It would try to reuse it. It has got both read and write capacity. So you can write to that foreign table or you can read from that foreign table. You can do inserts, updates, deletes. You can build this Mongo foreign data wrapper by using the legacy driver of MongoDB, or you can use the master branch of MongoDB. You have both the choice. By default, it will do it with master branch. And if you notice in my make install command, I have tried to install it with master branch. Now, once the whole setup of foreign data wrapper has been completed, you need to go ahead, connect to the Postgres database, and create Mongo FTW extension. If you want to create this for all your databases, I would suggest you to create that in the template database and use that template database for creating your databases henceforth. So all the new databases will inherit this foreign data wrapper as well from the template. Once you have done that, you need to create a foreign data server. So this foreign data server is basically a mapping or rather a connection to your MongoDB database, where you will specify the IP address of Mongo S server. Mongo S server is basically a query router which works as a query router and routes the queries to different shards. So it will contain the IP address of your Mongo S server and the port number along with username and password. After that, it will only contain the IP address and the port number. And after that, you need to create a user mapping separately. So this user mapping would be effectively telling Postgres that when I request for something with a Postgres user A, in return at the backend, you must be using this MongoDB user. So basically, you are creating a synonym or a wrapper over an existing MongoDB user so that you can create connections using that user to the foreign data server. Once the mapping has been created, you can use that to create a foreign table, and this foreign table would map to MongoDB collection. Here is an example along with syntax. So I have created a Mongo foreign data wrapper. This command should succeed. If it is failing, that means that your foreign data wrapper has not been compiled and installed properly. Once the extension has been created, you can create a foreign server using address and the port. And once you have done that, you can create a user mapping like you see on the screen. And then you create a foreign table like what you see here. So in this foreign table or in this collection, I have fields ID, warehouse ID, warehouse name. ID is a standard object or object ID in MongoDB. We'll discuss that later on. And then there is a timestamp field, warehouse created, and I'm specifying the details of the collection and the database. And I'm only telling that you need to use Mongo server for this. So I don't have to provide the complete details of the server again. I can just use the server name that I have created earlier. Now, in this case, let's say because MongoDB is a flexible data store and a particular field might be missing in the target DB in the MongoDB. So let's say for a particular record, warehouse name is not existing. And when you try to fetch data for that, it will actually come as null. We'll see this practically. We'll see that in a while. Underscore ID is a special column in MongoDB. It is used to store unique IDs, which are record identifiers. By default, you can skip this in MongoDB, and MongoDB will actually insert a 12-byte BSON object ID. But while inserting data via Mongo foreign data wrapper, you have to define this ID column with a specific data type called name. Like you see in my definition of foreign table, underscore ID has been defined as name. This is a specific data type which is reserved for underscore ID. So you define your underscore ID always as a name. And whatever value that you insert in underscore ID, it will be ignored. MongoDB will insert its own value like how it does when you have not provided an ID field while directly inserting to MongoDB. Once you have done this, your hybrid data cluster is ready for your usage. You can connect to Postgres and you can insert data or update data or delete data by firing SQL DML operations. And when you do that, like what you see on the screen, when you do that, it actually goes and does an insert in the MongoDB database, which you can connect and verify. So you can connect to your MongoDB database and you can see, you will find all those rows that you have inserted from PostgreSQL. Not rows, rather records. Because again, like I said about entities, rows is a term which is very, very particular to relational world. So I would rather use the term record to define data stored in MongoDB. In Postgres, you can use queries with where clause, or you can join these foreign tables with another native table or a foreign table. You can also collect statistics on these tables. So because Postgres has a cost-based optimizer, so you can collect statistics on these tables, on these foreign tables. Now, let me take you through a live system that I have set up on my system, on my laptop and my virtual machine, where I will show you how things work out in real. So here is a MongoDB instance. So if you see, this is where I have all my files, all my MongoDB stored. So all these data directories belong to one or the other MongoDB instance running. And I'm going to connect to my Mongo S server. Sorry, to my Mongo S DB. db dot, and I'm going to use my db. I'm going to change my database context to db. By default, it connects to test, like you can see on the screen. Now I have changed it to db, and I'm going to get data from warehouse field. So I have just the example that I have explained you in the slides. I have just tried to implement the same thing over here, and I'm going to show you that. It's taking a bit of time. Let me just make sure all my MongoDB services are running. So I've named my services with new underscore prefix, and I see all of them are started. So why is this? Yeah, so you see all this data being returned. I can say IT. By default, this result set is restricted to just 10, I believe, or 20. And if I say IT, it will return me more results. What I can rather do is, I can say count of all these, which is around 28. So currently I have got 28 collections here in MongoDB. Now let me connect to my Postgres database. Okay. Let's start from warehouse. So warehouse is a foreign table that I have here, and it has listed all those 28 rows. See them? You see them? And then I can actually, okay, now if you would want, I can insert a new record, warehouse values. Just check the table structure. So I can actually list my foreign tables using DET. So you see this? I can list all my foreign servers and foreign tables with these commands. So let me list them for you, /des. So I've got currently one foreign server, which is based on Mongo FTW. I can also list down the users. So here is a user mapping for Postgres user. For the server, Mongo server, this Mongo server is same as my external server here. And I can also list the external tables. So warehouse is an external table. I can also fire a query where I combine warehouse with another table called orders. Okay, sorry, that is orders, not order. So you see, this is a join result. So orders is actually a table inside my database. It's a Postgres table, which is on this particular database where I'm currently firing queries. So I can do joins. I can select data from here. I can update the data. Where warehouse ID is more than equal to 1. Sorry, I'm sorry, this is a syntax mistake. I was in the middle of another statement and wrote delete there. My bad. So I'm firing a delete statement now. I missed the, okay, let's, okay, this seems like there's an issue here, but because I guess I had a replica set and I had done some kind of promotion, it seems. But I can collect statistics. Seems to be an issue with my collection at the moment. There seems to be an issue with my MongoOS server. So I'm going to restart my MongoOS server. I'm going to restart all my services one by one because it seems while testing out, while preparing these servers for the Hangout, I have done some additional configurations. Okay. I guess there is something wrong with my sharding setup at the moment. Let me connect to one of the shards individually and confirm their status. Okay, I believe this is happening because of the new service that I see here. 30. So it seems this was not yet configured and things should work fine now. So you see this update is successful now. So the issue was while trying out different things, I had tried to add an additional shard while this whole hybrid cluster was up and running, which means I have already set up a sharded cluster. I have already set up a foreign data wrapper from Postgres to MongoDB. My daily usual operations are going on. And meanwhile, I see that my current setup, which is 3-node cluster, is not enough. And I need a 4th shard here or a 4th distributed data node here. So all I need to do is what I have here on the screen. I just need to make a new directory. I need to set up a MongoDB cluster or a MongoDB instance on that. And then using MongoDB service. And once I have done that, I need to start that. I need to start that as a replica set, which is something which I had forgotten to do. So once I did that, once I configured that part of it, things work fine. So as you can see here, I can do the updates as well. Another important point which you guys should have noticed, this is something which I had not planned to be in the demo, but you guys would have noticed that even though one of the members of this sharded cluster was not healthy, which is E. So this particular service E was not healthy, but still the read queries were not getting impacted. Still, I was able to continue with my read queries. It was only when I was trying to do analyze, or when I was trying to do an update, it was failing, but the read queries were continuing just fine. So this is quite fault tolerant as well. Now, if you see, let us connect to, let us try to insert a new value here. Let us try to insert a new value here. So I'll pick up something from my presentation. I'll pick up one of the rows from here, and I'll just modify that same row. We call it SHN, and I'll use, remember that I had used, I've configured my shard key to be unique, so I have to insert unique dates here. There is just a mistake which I had done while setting this server, but you don't have to do that. You can have shard keys which are non-unique as well. I have inserted a new data here. Now let me try to check on my MongoDB server, and I need to first change to database DB, and you see that I'm getting more results now. I'm getting new set of data now, right? Because I deleted some data and I'm inserting some data. I'm able to do all that. I'm trying to insert the same value again, so which will not work out, and I need to change this to 30. So again, another insert in my PostgreSQL. Let us check, and I see that that same data is getting inserted here. Right? I can check the sharding status. I can check the sharding status of my database. Let me check the sharding status. Let me check. So let me check shard.sh.status. So in this, let me quit from here and show it to you once again so that you are more clear with what I'm doing here. So I switch to my database, which is sharded, and I check the shard status. So when you fire sh.status, this function will return you data about how many shards I have got. So I have got 4 shards at the moment, right? And I have got 2 databases added in the shard. Not 2, in fact 3 of them added in the shard, you see here. And then you can see that these are various chunks that I have. These are various data chunks, the split of data which is spread across multiple data nodes. So you see here, I have got some of my data on shard 1, some of that data on shard 3, some of that on shard 0. Like what you see here, if you notice it more closely, you will find that the minimum key and max key ranges are also provided over here for each of the shard values. and I can actually connect to individual databases. And then I can say use DB. I can say DB dot. So I can find out count on each of my databases. So like you see in this case, the database running on 27000 port is not having any data for my particular collection, whereas the next has got 16 records. Let me check in shard C, how many have I got? That has got 12. And how many records I have total? If you remember, the total number of records that we just saw a while ago was 28, right? And we see the same set of records over here as well. See, 28. And I can also add a new shard. So let me do that and show you how I can add a new shard here. So I'm adding a new directory here, and I'm going to add a new replica set here. Basically a new member, and that has been added. Sorry, I sometimes confuse between the Linux and the Windows commands. So the service has been started up. I have started the new service. Now I need to initiate. So I'm just gonna fire rs initiate, which will initiate this replica set. And I need to do now conf, which will configure, and soon after that you will see this f other will become f primary. So I have just started a new cluster, new MongoDB replica set with one member. Now I need to connect to my Mongo S server, to database DB. So you see this is DB this time instead of test. And I need to say sh dot add shard, and I'll say 7.0.0.1 27700. Okay, I need to use my machine name here. Okay, I have to use the set name as well as it. Okay. So I have added the new shard again. So basically the command I was, okay, this was a mistake on my part. Okay, so I have added the new shard as well. And if I say shard status, so you will see that there is a new shard which has been added this time. You see that there is a new shard which has been added this time with ID F. Right, so this is how you can add a new shard on the go as well. You don't have to bring down your operations if you see that the existing capacity or the existing servers are not enough. You can add new servers on the go as well. Main advantage, like I emphasized earlier as well, is that You can build a MongoDB cluster with an SQL interface. You can query MongoDB with SQL language, which means you can join that MongoDB collection with other MongoDB collections or tables in Postgres, or even other tables or other foreign tables which are coming from Hadoop or Oracle or MySQL. So basically, you are trying to build a hybrid data hub in Postgres itself. You can add more shards as your requirement grows. You can add replicas for your MongoDB database on the go. You can add a replica set. You can add a new replica for one of your shards as you go. So this makes your whole task of managing data quite easy, because you can do an insert, update, delete, or select via SQL statements into the MongoDB database. There are a lot of other foreign data wrappers available, like I mentioned earlier, for Hadoop, Oracle, MySQL, and there are some which allows you to read from Postgres dump itself, or you can use one which allows you to read from flat files. So stay tuned and look forward for more exciting, cool features of Postgres to be shared in upcoming Postgres Hangouts. Do send us your suggestions and questions if you have any for what you would like to hear from us in the upcoming Hangouts. And let me just go back to the Hangout screen and check for questions over there. So do we have any questions here? I'm not very sure because I cannot see the question answer app here. Let me check in the question answer app. Has anyone posted a question? Let me check. Sachin, are you there? Has anyone posted any questions?
No, Samir.
Okay, so do let us know. I saw there were a few pings coming in, and we have got few things in the chat as well, but I think we are running a little short of the time. So I see some questions in the chat. So we will post answer to all those queries via comments in the YouTube video or on our Google Hangout page on Google Plus. So stay tuned and then keep sending your suggestions. They are quite helpful and they help us devise more real-time scenarios in our Hangouts like this one. Thanks a lot. Thanks for joining. Over to you, Sachin.